steps are practicing kind of like substitution where you have to solve for x and y. So it says, this first example is already set up for elimination. See how the x's are stacked, the y's are stacked, the constants are stacked on the same side of the equal sign. And what is y minus y? Those, when I add them together, will add up to 0. So you want to look for one of your variables to add up to 0. So in this case, I'm ready to do elimination. All you have to do is add your two equations together. So I have negative 4x plus negative 5x. So I have negative 9x's. My y values eliminate because I have 1y and I'm subtracting y. And then I have to add 6 plus 21. So I would get 27. Can you already tell what x is? See how easy that was to solve for x? All I have to do is divide by negative 9 and I'm finished with the problem. So divide by negative 9 on both sides. X equals negative 3. Voila. So if it's set up for elimination, you're actually making more work for yourself if you try to get y by itself, plug it into the bottom equation, do substitution. Literally in one step, I got here. I still need to plug it back in, either into the top or the bottom equation. Both of them look about the same. So I'm going to plug it into the top equation to solve for y. So I would have negative 4x, so times negative 3, plus y equals 6. It takes a little bit more work to solve for the other variable. So I have negative 4 times x, which is negative 3, plus y equals 6. What is a negative 4 times a negative 3? That's positive 12, right? So I have 12 plus y equals 6. And what's my last step to get y by itself? Subtract 12 from both sides. So I would get negative 6. So don't judge that method yet. I like it, especially if it's already set up. It makes my job pretty easy. And you'll see in example B, it's not set up for you. If it were me, I would solve example B by substitution. So do you see example B? See how it says y equals? I mean, I could just do substitution and solve this one. I just want to show you what you would do if you wanted to solve everything by elimination. How would I set this up for elimination? I need to get my x and y on the same side of the equation, like over here. So I'm going to subtract this 5x to the other side. So if I subtracted 5x, why don't you do this by elimination on this example? And then when it comes to next examples, if you want to pick a method, that's fine. But this is your resource page. So I just want to show you what happens if it's not set up for elimination and you want to do elimination. So we would rewrite the top example, negative 5x plus y equals negative 7. So all I did was subtract the 5x to the other side. And then the bottom equation can stay in the same order that it started in. So your brain needs to get trained. Oh yeah, this is set up. They're stacked up for elimination. But before you can add together your equations, I can't just add this together because I'll get negative 8x. I can't just add this together because I'll get negative y. I need one of these to add up to 0 and eliminate. So if something is stacked, but you need to do another step, do you see this y right here? It would be really nice if I could have 2y so that I could subtract the 2y and that would add up to 0. So what you do is you multiply either the top or the bottom or both by a constant. So I'm going to multiply the entire top equation times 2 so that I get the 2y that I want. Remember, you can do something to both sides of the equation. So if I multiply one side by 2, if I multiply the other side by 2, it's okay. So let's rewrite this top equation down here. So the distributive property, so I would have negative 10x, and then I would have my positive 2y that I wanted, and now I have negative 14. And I'm just going to kind of draw a little line through that top equation to kind of not look at it anymore. This equation at the top is now this equation at the bottom because I multiplied by 2. Now it's set up for elimination. So you might have to rearrange your equation and you might have to multiply by a constant. Now do you see these two y's add up to 0? Negative 2y, positive 2y. So I get negative 13x's when I add those together, and I get negative 26 on the other side. So what does x have to equal? Divide by negative 13, x has to equal positive 2. See if you can plug it back in. You can plug it back into the original equations, the multiplied equation. The very first equation up here that said y equals, that's going to be the easiest equation to plug it back in. I could do this in my head, right? Y is equal to 5x minus 7. I can just do 5 times 2 in my head minus 7. What would y have to be? 3. 5 times 2 minus 7. So y equals 3, and now I'm done. 2, 3 is my answer. So I think if you practice elimination a little bit, I like adding the equations together and then just solving for x or y better than substitution. There's less to write down. So let's jump ahead to page 109. Let's see which of these are already set up for elimination. It looks like number 1 is already stacked up, right? X, Y, constant. And I already wrote that it's ready to add together. Why don't you try example 1? See if you can add example 1 together. You don't have to do any multiplying. Add it together and see if you can solve for X or Y. Everyone see where we are? This is now skipping ahead to page 109 where all the practice problems are. See if you can tackle number 1. Add together the two equations. One of the variables will get eliminated. Very first step up here, that we would have canceled the x's, and we'd have that 7y has to equal negative 14. So all right, so my next step would be divide by 7 on both sides. There, you already have half of your answer completed, right? Y has to be negative 2. So now I need to take that negative 2, plug it into either the top equation or the bottom equation and solve for x. So I'm just going to pick the top equation. I would have 2x's plus 3 times negative 2 equals negative 4. So now I need to take that purple equation up here and solve for x. 2x plus, this would be negative 6 equals negative 4. So see if you can add the 6, divide by 2, and solve for x. Does anyone remember elimination from maybe last year? 2 years ago, you probably forgot about it, but my Algebra 1A, 1B people, does elimination seem like a familiar strategy? Okay. 2 years ago, during COVID, maybe you don't remember elimination, but let's see. Add 6 to the other side. 2x equals 2. So x should be 1 as my final answer. 1, negative 2. This is hard algebra, guys. This is just grinding through, solving the equation, combining like terms. It's not really fun. If you wanted to check your answer, you could always plug those coordinates back into both equations and make sure they work, right? You can always check you have the right answer before you're done with the problem. All right, so what happens if I'm lined up? So these are stacked, right? But if I add them together, nothing's going to eliminate. Can someone think of what could I multiply either the top or the bottom equation by to help me out? Yep, I could multiply the top equation here actually by negative 4, because see how this is a positive 4x? So I'm going to multiply the top equation by negative 4. So I like to just rewrite the problem next to it. So I would have negative 4x's if I distribute I would have negative 4y's, and I would have equals negative 16. So see how I multiplied every single thing in the top equation by negative 4. Then the bottom equation, that just stays the same. 4x plus 6y equals 10. So see if you can add those two equations together and get y, right? Because your x's, when you add them together, should cancel out. So solve for y. Come out as an integer. So we get 2y equals negative what? 6. Divide by 2. So y has to equal negative 3. Now you can plug that back into the multiplied equations or the original equations. I always go to the simplest equation, like x plus y equals 4. To me, that would be the easiest. So if I plugged in this number, I would have x minus 3 equals 4, right? Because x plus y equals 4. Plug in the negative 3. So then you can kind of quickly see that x would have to be 7 to make that true. Because 7 minus 3 gives you 4. So your answer is 7 comma negative 3. All right. Can I go on to another example? I want to show you how to set up number 3, and then I'm going to have you solve it. Do you see how I did it stacked up, but I can't just multiply through the top equation by a special number because I still have trouble. Like I've got a 2 and a 3, and I've got a 5y and a negative 2y. I need to multiply the top equation by one number and the bottom equation by a different number. And I like when there's a positive and a negative right here. So what, have you ever heard of the least common multiple? Like if I count by 5s and I count by 2s, where's the first number that they're going to match when I'm counting? Right, so you heard of that before? It's called the least common multiple. 5, 10, 15, 20, and I've got what? I'm counting by 2s. 2, 4, 6, 8, 10. So 10 is called the least common multiple. So you want to get them both to be at 10 so that they will add up to 0. So what should I multiply the top equation by? I'm trying to get this 5y to get to 10. So I want to multiply the top equation through by 2. What should I multiply the bottom equation by to get the y value to 10? 5. So this to me takes like most of the work because you've got to get them both into a new equation. So we're going to distribute 2 and distribute the 5. So you got to make sure you hit everything. So I got 4x plus 10y equals 40. And now I'm going to distribute the 5. So I've got 15x minus 10y. Let's see, I have to do negative 8 times 5 is actually negative 40. I don't think we've seen one like this before. What happens when I do my elimination? My y's add up to 0 and my 40's add up to 0. So I get 19x's equals 0. I want to point out there is still an x, right? It does not say 19 equals 0. It says 19x equals 0. What does x have to be to make that true? 0. So this actually does have a solution. It just works out that x happens to be 0. And a lot of students will jump the gun and say, uh-oh, no solution, right? Because you see a 19 equals 0, but it's 19x. So when there's still an x, you divide both sides by 19, and x equals 0. That's a real number. So you got to be on the lookout for one of your variables equaling 0. All right, I can plug this one back in just by pointing. Up here in the top equation, if I plug in 0 for x, I just get that 5y equals 20. What would y have to be to make that true? 5y has to equal 20, so y would have to be 4. Does that make sense? So y equals 4, 0, 4. All right, I'm going to do one more problem with you, and then we're going to skip to number 7, one application problem. And then maybe we can warm up with some elimination tomorrow. And I'd love for you to maybe start the first problem on tonight's homework so I can walk around and make sure you know how to set one up for the homework tonight that you started on it. All right, so number 4. Oh, it's not lined up, right? I've got my x, but what do I have to do to this y? I need to add it and bring it to the other side of the equal sign, right? The y over to the left. So I'm going to add y to both sides of the equation. So 2x plus y equals -4. I'm going to keep the bottom equation the same. -4x minus 3y equals 10. What should I multiply one of the equations by? You can either get rid of x or get rid of y. It doesn't matter to me. Top equation, what should I multiply by? Sure, if I multiply by 2, what am I going to get rid of? The x's. If I multiply by 3, what am I going to get rid of? The y's. Doesn't matter. Let's just do 2 so we can all do it together. I'm going to multiply the top equation through by 2. Right to what I get down here underneath. So I get 4 x's. I get 2 times this positive y is 2y. And then I get -8. And I'm just going to put a line through that top equation so I don't look at it anymore. So now, see if you can finish this problem. Do elimination on these 2 rows, right? Add them together. See if you can get x and y to finish that problem. It's not a trick. You've got to be paying attention. You've got -y equals +2. You need to reverse signs by dividing by -1 on both sides. You want y by itself. So y actually is -2 when you get the y by itself. That's a little bit tricky. You don't want to end with a -y. Okay, plug that back in. You can pick any equation. You can pick this equation, this equation, this equation. Pick one equation and plug it back in and see if you can get it. Yeah. Let me see. Get. I think I'm just going to pick this top equation up here. I've got 2x's equals the opposite of y minus 4, right? Because this would be +2. So let's see, 2x equals -2, so x would have to be -1. Did anyone get -1 as their answer? -1, -2 looks like the final answer. Oh, I just didn't show it to you, did I? So I took my -2 and I plugged it into this just top equation right here. So I wrote 2x equals, this would become +2 because it's a negative minus 4. So 2x was equal to -2, which made x -1. And then I wrote my final answer. Equations. Take a stab at it. It's a money problem. Dennis mowed the neighbor's lawn for a handful of money. He got 14 bills. Some were $1 bills and some were $5 bills. They paid him $34. So how many ones and how many fives was he paid? So what are you looking for? You have to define your variables, right? How many $1 bills and how many $5 bills? So you want like x to be maybe ones and y to be fives. See if you can write your 2 equations. One of them will be x plus y equals your total number of bills, right? And the other one has to be like the money equation from the previous example. See if you can get that one. I'll put. So come up with what my second equation would be about the money. How much does each one get? How much is each one worth? $1 bills and $5 bills. So it would be that each X is worth $1 and each Y is worth $5, and I have $34 total. I have a 1X and a 1X. So this is going to help me do elimination. But before I do elimination, I need to get one of them to be negative. So you either need to multiply through on the top by -1 or on the bottom by -1. I would choose the top because then see how your Y's are going to come out positive and your money will come out positive. If you multiply this -34, you're going to have negative amounts of money and deal with negative numbers. So if for me, I would multiply through the top equation by -1 to do elimination. So go ahead and multiply the top equation by -1, write it down here underneath, and see if you can do elimination and solve for your number of bills. -x, -y, -14. I get 4y equals 20. So y was $5 bills. Does that sound right? Because 5 times 5 is $25. And then you needed 9 $1 bills to get to $34. So this is how you answer an application problem. Instead of writing a coordinate, actually state like 5 pizzas, 5 buses, right? Because it's application, so you don't want to lose points on a quiz for that.